Hi, welcome back to LeetCode. Today I'm going to discuss LeetCode problem 3043. Find the length of the longest common prefix. So you are given two arrays of positive integers, array 1 and array 2. A prefix of positive integer is an integer formed by one or more of its digits starting from its leftmost digit. For example, 1 to 3 is the prefix of the integer 1, 2, 3, 4, 5, while 2, 3, 4 is not prefix, right? So a common prefix of two integers a and b is an integer c, such that c is a prefix of both a and b. For example, this is actually the input two number 5655 5655 359. Another number is 56554. So what is actually common prefix? You can check here also 5, here also 5, 6 also here, 6 also here, 5 also here, 5 also here, 5 is also here, 5 is also here. So this actually common prefix will 4 is here but not here, actually 3. So there's a conflict different. So this is, we can't take a prefix here, common prefix, not a common prefix. So 5 is 5655. This is our common prefix. So you can check actually here the answer is common prefix is 565. 565 also this is common, and 5655 also is a one common prefix. While 1 to 3, 1 2 to 3 and 4 3 4 5 6 do not have a common prefix. Yes, because it's starting with 1 and it's starting with 4. There is no common prefix. So you need to find the length of the longest common prefix between all pairs of integers x, y such that x belongs to the array 1 and y belongs to the array 2. Return the length of the longest common prefix among all pairs. If no common prefix exists among them, return 0. Right? So suppose for this example, this is array 1 and this is array 2. So they actually what they actually want actually, like array 1 actually content 1, 10, 100 and array 2 content only 1000. So we have to find out the longest common prefix. So what actually pair is possible? 1, 1000 between 1 from array 1 and 1000 from this array 2. Another pair possible 10, 1000. Another is actually 100, 1000. Right. So what is actually what is the common prefix of this? Only 1. So what is the length of this? Length is equal to 1 also. Now for this pair, what is the common prefix? Common prefix is 10. Right. 10 also present here. 10 also present here at the starting. So length is actually here actually 2. For this pair, what is the common prefix? Common prefix is actually 100. So what is the length of this? Length is equal to 3. Right? This is length. So what is the maximum length? Maximum length is actually 1, 2 and 3. Between 1, 2, 3. This is actually 3. So our answer should be 3. You can say the answer actually 3. Got it? If there is no common prefix at all, that time we have to return 0. So for example 2 actually. Okay. The array content, array 1 content 1, 2, 3 and the array 2 content all 4, 4, 4. Okay, so what actually pair are possible? First of all, these 4 will combine with all these 3, like 1, 4, 2, 4, 3, 4. Again, these 4 will combine with all of array 1 of all the members with array 1. So again 1, 4, 2, 4, 3, 4. Again these 4 will combine will again 1, 4, 2, 4, 3, 4. So for this pair, what is the common prefix? Empty. There is no common prefix. So what is the length of this? 0. Again there is no actual common prefix. So empty. So length will be 0. Similarly for this also length will be 0. These actually duplicate, so we can actually check or we can actually discard this. So for this you can check there is no actually common prefix, so ultimately we have to return 0 at the end. So that's why we have actually returned 0 from this input. So what actually have to do actually, like for this example array 1 array 2 what actually content 100, 500, 1000, 5000, 7000 and here actually 50,000, 7,000, 1,000. Now, what actually pair are possible? So what actually we have to find the longest common prefix. common prefix. We have to actually try to find, right? Whatever the maximum longest or maximum length, that we actually take. Now, what is actually the longest common prefix? Normally common prefix are possible. 100, then 10, then 1, right? First of all, we will try to, like, what is the common prefix are possible? Prefix are possible. All prefix are possible from 100. First of all, it possible 100. Then if we discard the rightmost digit 0, then we will get actually 10. If we again discard this 0, we will get actually 1. Now, we have to try to find the 100 is there or not. Try to match any from array 2, is there any prefix which is 100 present or not. We have to try to that. If it is not present, then we go to the 10. First our target should be matched with the longest, right? Longest prefix. So that's why first of all we will generate in this way, like 100, 10, 1. These are all first of all, in brute force approach, what to do? We have to generate all possible actually prefix are possible from array 1. Then we will store in some hash table or set. Okay, like here actually store 100, 10, 1. These are all possible actually prefix are possible from 100. Then from 500 we will generate this 550, then 5. Then from 1000 we will generate 1000, then 100 automatically actually it will actually handle that this 100 actually repeating. 10, 1. Then 5000 we will generate 5000, then 500, then 50, then 5. Then 7000 also similar, 7000. This is the longest common prefix. Then 700, then 70, then 7. Right? These are all possible actually. All possible prefixes are possible from array 1. You can check all like this is the worst case. All possible actually prefixes we have generated. Now from array 2 actually we will traverse. What will to traverse? First of all, we will get the number 50,000, right? Then we will try to match this because if there is any match found, any prefix are found from this set, from array 1 set that we have generated or store all the possible prefixes. First of all, we have to match that. Our target is to maximize the length. So first of all, this is your maximum length, our input. I'll try to match this as a prefix, common prefix from the set that we have generated from array 1. If we found any match, then I will actually compare this length. So suppose here actually I will check with 50,000. Is there any 50,000 number in the prefix possible from array 1? No. So now we will just discard this last digit. Now our target is 5,000, right? This is our current actually. If we discard current next possible prefix, next possible longest prefix, now I will try to take match that this 5,000 actually present or not. Yeah, this is actually present here. You can check actually this 5,000 is present. So this actually one possible actually longest common prefix from this. So I don't have to check to the go to the next 500 or present or not, 50 present or not, 5 present or not, because we already matched this is your longest. So I will just modify this our answer. Our answer initially will be 0 because we will expect that there is no common prefix. So initially at that time I have to return actually 0 by default. So here actually we are initializing this variable, global variable answer with 0. Now whenever we found any match, like here actually you can check 5,000 we got a match. So what is the length of this? Length of this 4. Sorry. So I'll just modify this 4 because this is actually the greater than the previous value stored in the answer. So current answer length, maximum longest common prefix length is 4. Got it? Now next number is what? Next number is 7,000. Right? Next number is input from array 2 is 7,000. So what is this is actually initial first longest prefix. I have to try to search that from array 1. So I will try search 7,000. Yeah, 7,000 also present here. You can check 7,000 present here. So what I will do, I will match here. And what is the length of this? Again 4. So I'll try to modify the answer variable. Okay, then I will say okay, already this is 4. I do not have to modify this. Okay. Now I go to the next element from the array 2, 1,000. So first of all, this is our longest possible prefix, right? So I will try to search 1,000. Is there any 1,000, 100, 10? This yes, 1,000 also present here. So this is also matched. This is our one possible actually longest common prefix. So I will actually, what is the length of this? 4, again 4. So I will not modify this because this is already 4. Now you can check, actually we have already checked all the pair possible from array 2 and array 1, between array 1 and array 2. Then we got the answer is actually 4. Then here for this example, our answer should be 4, right? Understood? So in brute force search, what we have to do, how to do, like first of all generate all the possible prefixes from the array 1. Generate all this and store here actually in set or map, that actually we can actually easily search that. Otherwise we have to again to search that, right? So to optimize the search operation, we actually store in has set or a has map. So here actually you can check that from 100 we actually generated this. We will store this. How actually you can generate this? Like first of all we will get one number, suppose value will be 100. Then we will store this set insert 100. Then what will do till our value is greater than 0. That time we will also store this. What will store? I will just divide it value by 10. Then it will actually discard the rightmost digit, and we will actually got the next longest prefix from the current number. And then again we will store that. In this actually we will continue till how, like we will go to the actually till 1, and again if we divide 1 by 10, this will give us a 0. That time we do not have to store that, right? Got it? And similarly for this, in this, then after storing all this number, we will again start traversing the array 2. Then we will got one number again, and again we will actually similarly we will here actually not insert this. We will just search from that set, that whatever the number we got currently, set.search or set.find the current value. Okay, initially search, and at the end we will modify the answer variable. If this is clear brute force approach, please like the video, and if you still don't doubt, you can also comment on that. Okay, now go to actually the one more advanced data structure that will help us here actually optimize this. How actually you can check actually, like here actually what we're doing, we're generating all possible actually prefixes from array 1. So here actually you check that if the length of each word, suppose each word means here actually number, suppose 1000. Okay, length is actually 4. So how many actually prefixes are possible from this number? 4 number are possible: 1000, 100, then 10, then 1. Right? So we're generating 4 number that in brute force approach. So what do we do? If there are 4 number, length is 4, then input number, then we have to generate 4 number. So that we can optimize this by using the Trie data structure here. This is advanced data structure. So here actually how actually you store, like we will store in a number, in a tree type format. How? First is starting with 1, then is starting with 0 again, because the next digit is 0, next digit is 0 again, next digit is 0 again. Okay, in this actually we will store this. Okay, similarly for another number is actually 100. Similarly for this, suppose this is actually root. Okay, from root actually we have actually inserted this 1000. We have already inserted this 1000. Now we have to insert 100. How actually insert? Again we will check this is one child. Yeah, we do not need to create a new node of value 1, and again go to the actually 100, right? So 1 I have already checked, this is actually one node. Then again next digit is 0 again. Okay, I will check the, okay, 0 is already present, that node. I will need to create new node with value 0. Next I go to the actually next node, that is our actually 0. I will again check the 0 node is already present, so I do not need to create new node for this 100, right? But already 100 is inserted. Now next number is 500, right? So under root node I will search 500. So next first digit is 5. I have to search 5 here. 5 is not present. I will create a new node with value 5. Next is 0. Under 5 there is node with 0. No. So I have to create this. I have created this node with value 0. Again next digit actually 0. I will create a new node with 0. Okay, next is 1000, we already stored this. Next is 5000. Okay, so from root again we start from here. First digit 5, yeah, 5 is already present. Go to the next 0, 0 is already present. Next is 0 again, already present. Here actually 0. You can search that there is no node with 0, so I have to create this. I have created this and stored 5000. Okay, now we want to store 7000, right? So there is no node with 7, so I'll create a new node with 7. Under 7 there is any node 0? No, because there is no child, this is empty, so I have created this. Next digit again 0, there is no node with 0. Again the last digit is 0. Got it? So now you can check this actually, we have stored all the actually numbers in this format. Got it? Like there are a root node, and under this root node we will created all actually the values starting with, like you can check there is a node with starting with 1, number starting with 1, next is starting with 5, next is starting with 7, right? Now what you have to find out the common prefix, like you can check actually whatever we can actually do actually longest common prefix. So first of all I will search that, suppose the number is actually input number is suppose 50,000. This we already generated from array 1, right? This actually this tree right format. Now we want to find the longest common prefix from number 50,000 from array 2. Now what will search? First we'll search that this 5 is present or not. Is there any number with starting with 5 or not, right? So what I'll do, first of all we will search under root node. Is there any node 5 value? Yes, this is present. So I'll go to here actually. Okay, now our current length is actually 1. Common prefix, longest common prefix, now it is 1. Next digit actually 0. I will check, is there any node with 0? Yes, this is 0. Now I'll come to here actually. Now our length modified to 2. Okay, now next digit is 0 again. So I'll search under this node, is there any node with 0? Yes, this is present. So I'll come to here and length will be increased by 3. Next digit is still 0 again. I will search 0, node value 0 under this node. Currently I am in this node actually. So I'll search here, I'll say okay, this actually node is present. So I'll come here and length will be increased by 4. Okay, now next digit actually 0. Is there any node with 0 under this node? No, so we can't go to the actually any common prefix starting with this. So you can check the longest for this number for 50,000, the longest common prefix length is 4. You can check that actually 4. You can actually verify also. So that's why our answer will be modified. Initially it was 0. Now I'll modify this with 4. Got it? Got it? It is clear. Now for what is the now next number from array to 7,000. 7,000. Okay. So what is the first digit? First digit 7. So I'll come to again from root we will search. Is there any node 7? Yes, this is present. So our length will for this length will be 1 now. Okay. Now what is the next digit? Next digit is 0. I'll search, is there any node 0? Yes, this is present. So I'll come to this and length will be increased by 1 and it will currently 2. Next digit again we have to search 0. Okay, is there any node of 0 under this node? Yes, this is present. So I'll come here and length will be increased by 1 and it will be currently 3 ultimately. Next digit again search, next digit is 0 and we have to search this under this current node. Is there any node with value, any child node that is value is 0? Yes, there is a value 0 node value is present. So I'll come to here and length will be increased by 1 and ultimately this is 4. Now we have already iterated all the digit from the input array and we have completed. Now what is the final, what is the length of the longest common prefix? This is 4 and our answer is also 4, so you don't have to modify this, that this is 4. Ultimately we store a 4. Got it? In this actually we will search this. How actually you optimize this? Like you can check actually that we are not generating all possible actually prefixes from in array 1. Like you can check actually what actually common prefix are possible. 5 from 5,000, 5, 15, 500, 5,000, right? Now you can check actually we're generating only we have to generate all the things but only storing only one times. Like you can check actually 5 we have created, we can actually go to the 5 actually. Then if we go to the down, then we will generate 50. If we come here, then it will be actually generating 500. If we come here, it is actually generating 5000. Right? This is generating all the possible actually prefixes, but we are storing only one times. Space actually optimize this, and the time considered here actually we have to search like only one times. Like whenever we got matched, then we can go to the actually download, if it is possible. If it is there is no starting number with 5, then suppose this hierarchy is not present. This hierarchy, whole hierarchy, only starting with 1 and starting with 1 is present. Do I need to search any like any number with starting with 5000? 5? No possible, because there is no digit starting with 5. We don't need to search. But in the brute force search, what we have to do? What we have to do? First of all, you search with 50,000. Then okay, because this is the longest. If there is no match, then I will actually truncate this with the next longest possible. This will be actually 5,000. Still we are searching. But here actually, whenever you see there is no actually digit starting with 5, then we need to continue that. But still we are continuing this. Here actually you can check actually. Then we are not, there is no match with 5,000. Then we will actually truncate this 500. Still we are searching this. Then 50, then 5, right? Still we are searching, but in this way. But if we use the try here actually, in the first time we can actually say that there is no number starting with 5. Length will be 0. Longest common prefix length will be 0 for this pair. Got it? Got it? Understood it? How actually optimize this here actually? So now go to the code actually. Still you have any doubt, actually comment on that. I will also planning to make actually try series to make all the actually question. Okay. Now come to this code actually. So this is actually our main function where we're passing array 1 and array 2. Okay. So I'll create actually try root node which we need, right? So you can check actually try root node here actually means there is a node with actually 10 child are possible. Why? Because there actually digit, what is the digit are possible? 0 to 9 digit value possible each position. So you can check that how many actually total nodes are there? 10. So that's why creating 10 child node for each node. Like suppose we are currently for 0. So what is the possible child are possible? 0, 1, 2, 3, 4, 5. That's why for each node I can actually maximum 10 child. So that's why creating a 10 child for each node. And this is also for try node again. Okay, because this can also go to the actually under 0 there can be also node of 0 to 9, right? So that's why now we are creating a root node. Okay, now for root node initially we are actually all child will be null, because there will be no child for root node. There will be no child for each digit 0, 1, 2. That's why you can check that we're iterating from 0 to 10, where for each position I am actually assigning null initially for root node, because before that we have not inserted any we are not started processing from array 1. Okay, now you can check actually there is a node with all the values are actually null. Okay, all the values mean 0 to 9. There are actually 10 child are possible. Now we are starting actually processing array 1. Okay, we will get a number to string. We're converting the string and passing the root. Root is a constant and insert into a function that actually create the try data structure. Okay, and we will actually explain this function how actually creating that in code level, that how actually we are actually generating this try data structure, tree type data structure. Now we have created the try. Now we have actually started the processing of array 2. So first of all, convert this as a string, and again from root actually started the processing again. I have actually explained, like under root we'll search is there any digit 5 or not, node 5 or not, right? So that's how you can check actually for each position. Like we're actually currently we converted this current number from array 2 into string, and it will be actually iterate from left to right. So first digit will be 5. Suppose this will be 5,000. So first digit will be 5, right? So I'll check from the temp is currently root. Under root there is any child value, that will be index value, like 5 minus 0. If I convert this, it will give the actually 5, index value 5. I'll particularly go to that index. I'll check if it is not null. That means what? There is a child with already value. So this is actually common prefix. Common prefix, and this is actually part of the common prefix. So I will go to the actually I will increase the count. Count initially 0 for this current actually hierarchy for current number. The longest common prefix will be initially 0, and I will increase the count whenever we get a node with that value, and I go to the actual that node. I have to shift at that like 5000. So we have created 5000. So we got a match with 5. So next our search will be 0. So currently I am in root. I will check that any node value 5 is present. Yes, this is present. So I will come to here, and our length will be increased with 1. You can check actually. We will increase the count, and also temp is currently root. Previously it was at root. Now I shifted this. Temp will be temp.child, temp arrow child j, that particular index. Now temp will be point here. Okay. Next again it will come to this for loop again. Next digit will be 0. I will search that under this temp node, this node temp child particular, that 0 index is not equal to null. That means there is a node with value 0. So temp will be shifted here, and length will be increased by 1. Currently it is 2. In this way actually we will actually check. Whenever there is no match, I will break here from that point time. Here actually it is optimized, right? I have explained from brute force approach that how actually optimize this here actually. I will break from here, and whatever the actually count, the length, it will actually indicate the length of the longest common prefix for this particular number. So I will actually modify this. I will try to modify this with the answer variable. Answer is initially 0, and I will try the current maximum length of the common prefix, and ultimately at the end return the answer, whatever the answer stored in there. Now how actually you are inserting into the trie node, into the trie data structure, right? We have explained in the logical level at the before actually. Now we come to the code level actually. Now you can check actually temp will currently point to the root, because root will be always constant. This will always point to here actually. Now temp will actually just insert this and do the operation, all the operation. Now we'll check, we are just iterating the string, input string s, and temp is currently pointing to the root, right? I'll check under this root node, is there any child that is to null. That time, that means particular that index I minus 0, that usually index size is 0 to 9. I'll check that is null means what? There is no previously, there is no child on that particular value. So that time I have to create a new node for this index. So that's why you can check actually whenever it is equal to null, we are creating what? Temp.child, that particular index will be new trie node. We are creating a new trie node for this index, and we are also initializing all the child as a null for this particular child. You can check child I comma 0, then child k is iterating from 0 to 10, and we are assigning null. Now temp will be shifted to that particular index. If it is null previously, we are creating that, so that's why there is no problem. If it is already created, that time we just will come here and we'll just shifted that, right? There are two possible. There is no node before on that digit value, so that time we will create that first, like here actually creating that, and we are initializing that. Then we will come to here, else it is already created, then directly come to that node, because we don't need to create again. We'll come to here actually, and we will just shift this, and we again try to the next digit. In this actually you can check actually for 5000 we will got a root, then we will insert 5, because there is no node with value 5 at the index 5. So I'll create this, and I'll go to the temp will be shifted here, and I'll create a new node with 0, because there is no actually node with value 0. Again I will create this, and temp will be shifted here. Now again for 0 I will create this. In this actually we will actually creating this, whatever the actually digit we got from this input string s, right? Got it? So what is the time to this? Like you can check actually this insert function is calling how many times? If there is suppose n1 and n2, n1 numbers are present from array 1, so n1 times we are calling, and length is suppose l1. So time will be n1 because we are iterating each character by character from the input number. So the length of the suppose input number is suppose l1, average length l1. So that time we're actually for average, for each time we're actually iterating l1 times this for loop, l1 times average, and we're calling this function n1 times. So time will be big of n1 cross l1. Now again we are actually iterating suppose n2 times, because there are actually n2 numbers present in array 2, and for suppose length is actually l2. So we are searching this, iterating this each digit again character by character. because we are converting this first string, then we are iterating character by character. So that's why the average length is L2. Then time complexity will be N2 cross L2. So you got the time complexity. Time complexity will be ultimately big of N1 cross L1 plus big of N2 cross L2. Got it? In space complexity, space complexity will be big of N1 cross L1. Why? Because there is usually N1 actually the total number of actually present, and L1 is the average length. Suppose all are distinct, that time we actually create this new node for each digit, right? Otherwise it is like duplicacy. That time we are not creating new node only once, and we just shifted this. Like just how it's possible? Like 50, one number 50, 500, 5,000, 50,000. That time we will not create new node for 15. We will not create 500, 5,000. Also not possible. Only 50,000 we will create a node. It actually contain all of this. This will be content. 500 also will be content. 5,000 also will be content in 50,000. That's why we will create only once. That will be shared, right? Got the logic? So space control that time actually optimized, but if it is all are distinct, that time space control will be a little more actually. You understood? So please try to actually implement the code. First brute force approach, then try to implement the try code. Actually it is easy, just only the logical, because here is a structure here actually, structure variable. Okay, and still if you have any doubt, you can comment on that, and if you have any feedback or suggestion, then also you can comment. And please like the video and subscribe the channel if you're not yet subscribed. Thank you.